So in this presentation, I want to discuss transformers. Transformers is another very important part in the piece of the puzzle in understanding electrical circuitry, especially in HVAC equipment. We need to understand how the transformer works and how we're able to take one voltage and either step it down to another voltage or step it up to a higher voltage. So a transformer is, in many cases, nothing more than a piece of equipment that will, it's a non-mechanical electrical device. What does that mean? It means that there is absolutely no moving parts whatsoever in a transformer. Okay, a transformer is both a load and a source in an electrical circuit. The primary side of a transformer uses electrical current. We're using electricity to produce electricity, which would be our secondary side of our transformer. Okay, so the primary side of the transformer uses that electricity to produce electricity out of the secondary side of the transformer. And here is an example of what we're talking about. Over here, if we were to draw a line right down the center of this transformer, these wires over here, this would be representing our primary side. This is where power would be coming in to our transformer. This, on this other side, would be our secondary side of our transformer. This is the power that is actually going out of the transformer. Notice in the center of this device we have a gigantic piece of iron. It is this iron that is what does the magic in a transformer. Okay, so the transformer is constructed with a primary winding and a secondary winding. Okay, we are using applied alternating current as our source for our primary side. So this could be 120 volts. This could be 208. This could be 480 for all we know. Anything that is being applied to the primary winding, we are now going to produce on the secondary side. It's going to have less than what the primary side is. It all depends on how the transformer is constructed. That will determine whether or not I am going to increase the voltage that's coming out of my secondary, or am I going to decrease the amount of voltage that's coming out of my secondary. Okay? So like out of this case, like since the primary side has much more windings than the secondary, this guy would be stepping down. This guy might actually maybe only be putting out 24 volts by the time it's all said and done. So the primary side of the transformer, this is the side of the transformer that voltage and current is applied to. And it is the set of windings that is wrapped around the iron core. We've discussed relays in a previous presentation on how when I apply electricity to an iron core, I generate magnetism. Well, that exact same concept applies to a transformer. When I am applying electricity to that set of windings around an iron core, I am generating a magnetic field. Okay? Those windings are going to generate that magnetic field. It is that magnetic field that is going to step up and carry down the voltage to my secondary side of my transformer. The secondary side of the transformer is what reduces your electrical current. And these are the windings that are also wrapped around a magnetic core. Okay, the secondary side is electrically isolated from the primary and it is its own circuit. When we are troubleshooting a transformer, we need to make sure that we troubleshoot both the primary side of the transformer and the secondary side of the transformer all by themselves, because those two windings do not touch each other in any way. It is all done through that magnetic field that is being generated. We have types of transformers that are out there. We have step-down transformers, which reduce the voltage from the primary to the secondary. We have step-up transformers, which are going to increase the voltage from the primary to the secondary. And the ratio of those windings between the primary and the secondary determines how much the voltage is going to be changed. Okay, so for example here, like the amount of voltage that comes out of the secondary coil of a transformer is dependent on the incoming voltage on the primary winding and the same number of turns in each of those coils. So if a primary winding, we'll say, has 100 turns and that secondary winding only has 50 turns, the voltage exiting that transformer is going to be about half the voltage that was just entered. So we can see here in this diagram that we have 120 volts entering our primary, but through that magnetic flux and that magnetic generation that is happening here, and the less windings on the secondary side, I'm only putting out about half of what was coming in to my transformer. So therefore, this is a step-down transformer. I'm taking the voltage that is coming in to it, and it comes out much less than what was originally put in. If the primary winding had 50 turns on the secondary and 100 turns on, 50 turns on the primary and 100 turns on the secondary, then that voltage would be greater on the secondary side, as you would see here. So here's my primary side. I'm only putting in 120 volts, and I only got 50 turns around that iron core, but yet then I come around and I take 100 turns on my secondary. I'm able to step up my voltage. Okay, transformers are rated by voltage on the primary side and volt amps on the secondary side. So most primary voltages in HVAC are either going to be 120, 208, 230, 240, or maybe 480. Your secondary side in HVAC is going to be 24 volts. However, in reality, you are going to see a range of anywhere between 24 and 28 volts coming out on your secondary side. Your symbols for your transformers are as follows. This is how it would look in a diagram. This would be our primary. This would be our secondary. This would be the iron core. Okay. This would be a standard step-down or stepped-up transformer. If it was a little more in-depth, it would actually give us a voltage, say maybe 120 on this side, and it would tell us 24 on this side. Or if it was a step-up transformer, it could be 120, and it would be 15,000 volts. Okay, those designations would be on your symbol to tell you whether or not it's step-up or step-down. Another symbol that you may run into is your multi-tap transformer. Multi-tap transformers are used like as a universal transformer where we're able to wire a different voltage or a different primary voltage for a particular unit instead of having a crazy amount of transformers in the back of our truck. We can use a multi-tap transformer where I'm able to use it almost like a universal replacement for my circuitry. So like if, for example here, if I had a 120 volt circuit that I needed to wire, I would just simply wire my white and my black wires to give me 120 volts, and then I would just wire nut separately my red, orange, brown, and gray. They were no longer used. But if I needed to wire this for a 240 volt primary circuit, I would take my orange and my black and wire those, and then wire nut separately my white, my red, my brown, and my gray, because they would no longer be used. And then my 24 volt circuit would be just my 2 wires like it would normally would be. Okay, it's just another variation of transformer that's out there. However, the concept is still the same. I still have a primary side. I still have a secondary side. I have to troubleshoot each as their own separate circuit. And that's really about it for as far as transformers are concerned. They're nothing more than 2 separate windings wrapped around an iron core, and that uses magnetism that's either going to decide whether we're going to step up or step down voltage.